Look at any raw software directory, and you're looking at an architect's blueprint. The hierarchy of files reveals the operational intent of the engineers. This visualization of the Telecore directory shows 50 files. Highlighting the shell scripts reveals low-level utilities used for automated data ingestion. Yet sharing space with them are abstract files, like 15 core laws, and occult texts like the Lesser Key of Solomon. By reverse engineering this contradictory file taxonomy, we can reconstruct the machine's architecture. What emerges is an experimental AI designed to interact with its environment through a high degree of operational independence. We do not need access to the contents of these PDFs to understand how the system operates. Grouping these files by their naming conventions, extensions, and metadata sizes provides a clear map of the system's functional logic. This analysis reveals a 4-layer taxonomy: ingestion, interface, core logic, and governance. When we project that taxonomy outward, the flat list of files becomes a multi-layered functional map, separating the system's mechanical tools from its decision-making engines. Treating the directory as an archaeological artifact allows us to bypass the black box nature of the AI. We map the operational loop by examining the exact arrangement of its internal plumbing. The foundation of this architecture is Layer 1, a mechanical substrate dedicated entirely to automated data retrieval. This plane is defined by the executable shell scripts. These 5 bash files act as active nodes. At the outer edge, versions 1.0 and 1.1 of the Sentinel scraper pull raw external data inward. That external data routes through specific connection protocols, the drive connector and intake script. Once through that bottleneck, the media indexer and 2 Talla move variants sort the incoming feed into structured data blocks. These localized executable scripts suggest data ingestion is constant, running as a background process without waiting for external commands. Standard AI models are passive. They sit dormant until a user provides a prompt. Talla's foundation is built to independently hunt, grab, and index data across environments, operating as an active harvester rather than a reactive tool. Once that data is secured, it moves to Layer 2. This is where the architecture dictates how the system perceives the information. The second plane isolates a specific cluster of files designated by the Sentinel naming convention. The architecture maps these nodes to specific sensory inputs: ear, eye, hand, tongue, and voice. This moves the system away from a generic text processing model, forcing it to route incoming data through discrete, specialized functional modules. To manage these inputs, the system relies on the Nigagon dispatch system and the Perl emitter protocol. The dispatcher functions as a nervous system, ensuring that raw data from Layer 1 is routed to the correct sensory module for processing. By mapping inputs to sensory organs, the architecture forces the AI to evaluate multimodal data through specialized lenses, rather than a homogeneous data lake. At Layer 3, the perceived data is actually evaluated. The third plane links a sequence of core files, including the registry and identity nodes, into a central processing hub. This layer is governed by a structural document titled the Local Model Bridge. This bridge acts as a mechanism connecting a localized execution engine to the heavy computing power of cloud-based large language models. The engines and sources files act as localized filters, determining how the vast cloud intelligence is applied to the drive's specific data. Meanwhile, the registry and identity files maintain the system's state, providing the AI with a persistent memory of its own operations. This configuration gives the AI a continuous, localized cognitive identity, preventing it from functioning as a temporary API wrapper. The highest layer is the most complex. It houses the mechanisms of system self-regulation. The top architectural plane contains the governance and core laws files, which act as boundary walls for the system's decision-making process. These boundaries are supplemented by an internal psychological framework, established by files labeled Psychology Mode and Delwin Psychology. Alongside these rules are documents focused on the system's lifespan, succession protocol, and steward designation. Incorporating a formal succession protocol into a software directory is a rare configuration. It suggests the designers accounted for the passage of time and changes in management. The steward designation indicates a design intended to function across different generations of human operators. Within this layer of rules and psychology sits a massive data anomaly, the Lesser Key of Solomon and AI PDF. This single occult text is over 21 megabytes, larger than all the core architectural scripts in the folder combined. Including this 17th century symbolic text in the governance layer suggests the system uses complex, non-literal hierarchies to categorize information standard datasets overlook. By embedding this occult text, the engineers provided the AI with an archaic, symbolic framework for evaluating human concepts through a non-literal lens. Long-term independent operation requires more than just logic. It requires an ontological framework. This makes psychology and succession structurally necessary components of the system. This is the completed structural model of the Tala core system. The operational loop begins at layer 1, where data is gathered autonomously from the environment. That data moves up to layer 2, where it is perceived through the specialized lenses of the sensory modules. In layer 3, the perceived data is evaluated by the core engines, leveraging the local model bridge for processing power. That evaluation is then checked against the laws, psychology, and symbolic frameworks of layer 4. Only after this verification is the final action executed outward through the sensory dispatchers, completing the cycle. This architecture creates a closed loop where code, perception, and philosophy are inseparable. Agency in this model is the result of that structural integration.